Hello, Math 1050. This is Mrs. Bricky, and this will be section 1.3, complex numbers. We have 6 topics. So by definition, I is equal to the square root of -1. In the real number system, square roots of negative numbers are not defined. They would give you like a domain error in a calculator, for example. So mathematicians decided to define a number which they call an imaginary number, which is the square root of -1. And because I is equal to the square root of -1, that means if we square I, it is equal to -1. So we'll be using those two relationships for some of these topics. Our first topic is to simplify radicals that involve negative numbers. So as we simplify radicals, if you have a square root of a negative number, it is equal to I times the square root of the positive number. So the square root of 13, this first example, would just be I root 13. If the radical can be simplified, you should simplify it, and hopefully you have a calculator that will just take care of that for you. So we have a negative in front of our root. That means our answer is going to be negative. That negative is just going to stay there. Because we have a square root of a negative number here, we know we're going to have an I in our answer. And then the square root of 4, the square root of 4 is just 2, so this will be -2i. And that one does not have a root in the final answer at all because square root of 4 is 2, so our root has been performed and is no longer present. Square root of 8 is not a 8 is not a perfect square, so if we take the square root of 8, it's 2 root 2. If you don't have a calculator that will simplify radicals for you, let me know and I'll show you how to do them by hand. Because this is the square root of -8, we would have an I in our answer, so it's 2I root 2. It is also okay to write it this way. Just make sure the I is outside of the root, not inside of the root. The negative is inside the root, the I is out of the root. But either of those ways of typing it is fine. All right, for the next example, we're going to need to use the multiplication and division property of radicals. So these two properties will apply. If you have root A multiplied by root B, it's the same thing as the square root of A times B. So the root operation you can perform the multiplication before you perform the root if it helps you. And same with division, you can perform the division before you perform the root, but that is only for real valued expressions. So if you are using these properties, you have to write your radical expressions in terms of I first. In other words, we have to do this step first before we can apply these two properties. So we have square root of 40 divided by the square root of 4. So if we rewrite these two roots, this will be 2I root 10 on top. So in your calculator, just make sure, if you're using your calculator to evaluate it or to simplify it, you would type in the root without the I or without the negative, and then you just have to remember to put the I in your answer. And then on the bottom, the square root of -4 is 2I. Those two i's can reduce, so our answer would be root 10. For this next example, we need to write our roots in terms of I first. So this is I root 6 multiplied by I root 11. Neither of those two radicals simplifies. So now if we combine, we have I squared. We have an I and another I for an I squared, and then a root 66. But I squared is equal to -1, so this is negative root 66. So you can see why that property doesn't work for imaginary roots, because if we had not written in terms of I first, we might have thought that this was equal to positive root 66 if we just multiplied those together, but that's not true. It's equal to negative root 66. Okay, so for this one, we have I root 10 multiplied by root 15. And so that's I root 150. You can simplify that in your calculator and get 5 I root 6. The root 150, if you type in your calculator, is 5 root 6. Okay, and then the last one, if we write this in terms of I, this is I root 42 over root 7. And so we can apply our property, our division property. So 42 divided by 7 is 6. So this is I root 6. Okay. So that is simplifying a product and a quotient. All right, so we're going to shift to thinking about complex numbers. A complex number is a number that has an I in it somewhere, an imaginary part. Complex number is usually written so that you have the real part of the number first and the imaginary part of the number second. That's called standard form. So -2 minus 3i is an example of a complex number. The number 4i is a complex number. It has a 0 real part, so we usually just write 4i. And real numbers like 6 actually qualify as being complex numbers. They just have a 0 imaginary part. And usually we would just write 6 and we wouldn't necessarily write the 0i, but it does qualify as a complex number. Kind of like a square is a rectangle. So, and then the real parts, they can be fractions. The coefficient of the I can be a fraction. They technically could be roots as well. So you could have something like this. That would be okay as well. The only qualification is that it has a real part and an imaginary part and separated by addition or subtraction. And the imaginary part, of course, would have an I in it. So we're going to do some operations with complex numbers, some adding and some multiplying. And when we're working with imaginary numbers, it's really just like working with polynomials, binomials, and trinomials, just with kind of an extra step of if an I squared shows up in our equation, we will, or in our expression, we will substitute -1 for that because I squared is equal to -1. Okay, so adding and subtracting complex numbers. To add and subtract a complex number, you just, it's like combining like terms with polynomials. You just add up the real parts. So we've got a 6 and a -4. So our real part is 2. And then our imaginary part, we've got a -3i and a subtract -5i. So that would add together to be 2i. So our final sum or our final difference here would be 2 plus 2i. Multiplying is a lot like working with polynomials. Again, we're going to distribute, but then we have to remember and use the fact that I squared is equal to -1. So if I distribute here, I have -15i, and for my next term, I have -20i squared. Well, anytime you see an I squared, you need to replace that with a -1. So we've got -15i plus 20 because we've got a -20 multiplied by a -1. And then you want to report your answer in standard form. That means we need to put the real part first and the imaginary part second. So let's try that with 2. So in this first example, we just had one distribution happening, but now we're going to have 2. So just like multiplying binomials, we've got to distribute the 6. So we get 12 plus 30i. And then we have to distribute also the -4i. So that will be -8i and -20i squared. Anytime I squared pops up in your equation, you need to replace that with a -1. So 12, 30i, -8i, and a +20. So to write our final answer, we want our real part first. So that's 32. And then our imaginary part second, plus 22i. Okay, so we now need to work towards our next topic is dividing complex numbers. Dividing complex numbers is quite a bit more difficult than multiplying complex numbers. So we have to use, in order to divide complex numbers, we have to use what's called a complex conjugate. So the expressions a plus bi and a minus bi are called complex conjugates. Just the sign of the imaginary part is the opposite. So if you have, 3 plus 7i, the conjugate would be 3 minus 7i. If you had 1 minus 4i, the conjugate would be 1 plus 4i. So the real part stays exactly the same, only the complex or imaginary part changes signs. So the reason that we're going to use complex conjugates is that if you multiply a complex number by its conjugate, it actually is a real number. So this would be a squared minus ABI plus ABI, and then minus B squared I squared. So what happens is that these two middle terms that have the i's in them, they reduce. They add up to 0. And then over here we have this I squared, which is the same as -1. So we get A squared plus b squared becomes positive because we have a negative b squared that's multiplied by a -1. And this is a real number. This doesn't have any i's in it. It is just a real number. So our goal when we are dividing complex numbers is to get an answer that is a complex number. And it will usually be in this form. So we'll have a real number plus an imaginary number. That's what our form is going to look like. Alex will accept it if you type it in this way. And any of your fractions that can be reduced need to be reduced. So the way that you divide a complex number is that you want to make the denominator a real number. And we do that by multiplying the numerator and the denominator by the complex conjugate of the denominator. And as we practice that, what that sort of procedure is will make sense. So we're going to do two together here. The first one is -5 divided by 4 minus 6i. So we want to make this denominator a real number. So to make that a real number, we are going to multiply the top and the bottom by its conjugate. So 4 plus 6i. Whoops, that's a 4. And it's okay to do this for an expression because this is just a super fancy number 1. Since we're timesing the top and the bottom by the same thing, we're really just multiplying by 1, which isn't going to change the value. It's just going to change the form of the expression. Okay, so on the top, that multiplication is not too difficult. -20 minus 30i. And on the bottom, when we multiply that together, we've got two complex numbers to times together. That's a 16, a positive 24i, a -24i, and a -36i squared. So I'm going to leave that numerator alone for just a second. On the bottom, we've got a cancellation. And this -1 over here, this I squared is a -1. So this bottom is really just 16 plus 36, which is 52, I think. Yeah. All right, so we've got -20 minus 30i over 52. Now, Alex will kind of accept that. It's not reduced enough right now. Alex would mark it wrong because you need to reduce it. We could reduce a factor of 2. 30 is 2 times 15, 20 is 2 times 10, 52 is 2 times 26. So if we reduce this, it would be this. And Alex will accept that as the answer. However, sometimes reducing these can be difficult. So if you like, and it helps you see it in the more proper form, you can split it into the two terms. And then you can use your calculator to reduce it. So if you typed this in your calculator, it would reduce it to -5/13. And if we typed this in our calculator, it would reduce it to 15/26i. So this is, I guess, maybe the easiest way to see that it is a real number now. It's a real part minus an imaginary part. But this one would be acceptable in Alex. Let's try that again. A little bit more complicated numerator this time. So we look at the bottom and we want to make that a real number. So we're going to multiply by the conjugate. Now only the imaginary part changes sign. The real part is going to stay as a -5. All right, so multiplying that together, we've got a -10 plus 12i minus 35i and plus 42i squared. So that's our numerator. In the denominator, the -5 multiplied by the -5 gives me 25. I'm going to have a -30i and a +30i. And then my last term will be a -36i squared. All right, so in the denominator, we definitely have those two imaginary terms canceling. And then in our expression, we have a couple of -1s that we need to substitute in. So we've got I squared on the end of the top and on the bottom. So this makes this last term a -42. So if I combine that with the -10, that's a -52. So I'm just combining this one and this one together. So that's a -52 is the real part. And then 12 minus 35 gives us -23i. And now on the bottom, we've got a 25 and a +36. So 25 plus 36 is 61, sorry, 61. So again, if you need help simplifying that, the best way would be to separate it and then let your calculator help you simplify it. In this case, it doesn't simplify. 61 is a prime number, 23 is a prime number. So you can either type your answer in this way or this way. They're both acceptable. Okay, last topic is simplifying powers of I. When you're simplifying higher powers of I, there's two rules that you want to use to help you. The first rule is that I squared is -1, and we know that, we've used that, and we're going to continue using that idea. And then the other rule is that if we have a power here, we can always think about it as a power raised to another power. For example, if I had x to the 8th power, I could always choose to think about it as x squared to the 4th or as x to the 4th squared. So we can break our powers up like that to help us. So what we're going to do to help us simplify these higher powers of I is that if we have an odd power, we're going to separate off one I. And then we're going to rewrite our even powers as I squared to a power. So I to the 28th is the same as I squared to the 14th, because 2 times 14 is 28. So we'll rewrite our even powers as I squared to a power. We're going to substitute -1 in for I squared. And anytime you have an even power of -1, that's just equal to 1. So our answer here is 1. So for this one, I'm going to write it as I squared to the power of 15. So that means it's -1 to the power of 15, and odd powers of -1 are equal to -1. So that one is equal to -1. Okay, this is the one that has the odd power. So if you have an odd power, you're going to separate off one of those i's. So one of them times, so it's I times I to the 102. I'm going to let that I chill and hang out for a second. And I'm going to rewrite this part as I squared to the power 51. Well, that's negative 1 to the power of 51. And that's an odd power of negative 1, so that's negative 1. And it's I times negative 1, so our answer would be a negative I. So your only answers possible here, whoops, I missed an N. The only answers possible here are 1, negative 1, I, and negative I. That's the only answers you'll get on this topic. It's got to be one of those 4. All right, so let me know if you have any questions on this section. The assignment is in ALEKS, and thanks so much.